about number 6?
It's, I know the digits are -1 and 0.
Okay.
I don't remember what order to put them, and I don't remember what order to flip them in.
Well, what is tangent normally? What over what? Nope. Yep, so cotangent is going to be, there you go. Yes.
I don't even remember how to do this. I'm embarrassed by the fact I don't remember.
Sine of 3 pi over 4, y value on your circle at 3 pi over 4.
Oh, I was making that a lot harder.
Wait,
It's usually what happens.
That's just
Wildly embarrassing. Because I'm trying to over here do math to figure it out. I have the circle in front of me and I'm trying to put things.
That's why I can ask you 5 of these in a minute and a half, because they're.
I know. Just, how did I do these?
Do that.
I was like, how did I do this? I quit. Never quit.
No quitting. Quitting's not allowed. Now you're just hearing things. Hints on if you what? I'm sorry. Like 1 through 6? Like you want more of them? Oh, sure. Go down here.
Yes, so I just text my brother and tell him I can't take it home because I forgot to tell him this morning.
Sure.
In my defense, he was in an awful mood this morning, so I didn't want to. Are you okay?
Oh wait, I didn't. Or did you? Oh, you didn't shift it.
I will see. But if there wasn't a shift, then I'll do it.
Yes. All right. Good job. Duncan asked for more of these, so that's why I'm squeezing it. 9, 10.
So. No, it's like like when you put something on, I said, I don't like that.
I feel like you're thinking way too hard on that. What are the tangent or the cotangent of all the over 4s? At all the over 4s, isn't it the x and the y are the same? Like maybe negatives and positive are different. And then you figure out positive or negative. You're like working so hard. I'm like, what are you doing? Yes. Guys, 9, 10, and 11 are just bonus if you want to do more practice on those.
It's a tangent. So it's pi over b. You know what it is.
Is it the opposite reciprocal or just the opposite?
Just the reciprocal. -2.
Oh wait, what do you I don't know. That's right. You saw that. She yearns for change. Why are we yearning for change? You're still like,
Yeah.
if you're
You can move. Pretty flexible. Like, I'd prefer you didn't sit somewhere different every single day, just because then I'm like, oh, attendance, who's here? Yeah.
Anybody yearns for change.
You're welcome to move.
I don't know if I can do that, but we're so funny.
All right, guys, let's go through these. So sine of 3 pi over 4, guys, that's just a y value of 3 pi over 4, positive root 2 over 2. Cosine x value, that's 4th quadrant, so it's also positive, 3 over 2. Tangent, you can use your shortcuts there. Remember the over 6s are always root 3 over 3, and then you figure out positive or negative. Second quadrant would be negative. Cosecant, think of it as sine first. So that's -1/2. So when I do the reciprocal, I get -2. Secant, think of cosine, which is negative root 2 over 2. When you flip and rationalize and simplify all that stuff, you get negative root 2. And then cotangent, remember, is x over y. If I'm over here at pi, that's -1 over 0. Guys, what's anything divided by 0? Undefined. Not 0. Okay. The bonus one, sine of 3 pi over 2 is -1. Cotangent of 7 pi over 4, also -1. Secant of 2 pi over 3, you can think through cosine of 2 pi over 3, which is -1/2, so -2. Okay, guys, if you're still like real slow at those, definitely practice on the delta math practice. It will help you get a little bit quicker. Or these are very easy to just make up, right? Just number a paper, right? Sine, cosine, tangent, pick things from your circle and then do them. Set a timer for yourself and practice. You have to do them to actually get better at them. Okay. All right, the graphing. Okay, we need a minute on the graphing? Okay. Another moment of graphing. Yes?
No, Sarah, you must hydrate.
Interesting.
Didn't I tell you to drink water earlier?
Yeah, I drank it all.
Okay.
I only had half the water bottles to begin with. But
Finished?
That news to correct it.
Let's see. Right side. Yes. Well, no. So, let's see. So normally this point is here, so that shifted over fine. But this point needs to shift all the way over to here.
Oh, I forgot to shift. That. Wait, didn't I shift them?
No, they're not halfway through. Like,
Oh, because I
and this one is like
oh, so this would be
here,
over here
and then your asymptote is
so I just did halfway.
yeah, like that's the goal. And then you should have this part filled in. Okay.
Well, at least I got the middle one.
And your shape is real.
Sad.
Yeah, it's just that. Okay,
And
it's
the 2
not.
points are right here.
You can't like add more strokes.
That's so
Oh, okay. So that would be wrong if I drew like
I would definitely take off for that shape. Okay.
That's kind of
So-
how I've been drawing the wall.
Like connect to there, connect to there. It's like half a
Oh,
parabola,
it's
the other half
that.
a parabola. Yeah.
I'm just bad at drawing parabolas. And that's why I try like that. So you know it's a parabola, even though it's like basically writing.
And then this one, the period is actually going to be 5, not 4 or 5.
Going to be because it's cotangent. Yeah,
Okay. So relabel that. And then the negative actually means the shape is going to look more like tangent. I'm going to flip it and go the other way. Because this is normal cotangent.
Oh, normal cotangent goes that way.
Yes. So when you flip it, it's going to be. Okay.
So yeah, I think it was base.
All those things are over there. More practice. Yeah.
I didn't just unload my whole pack on your desk. You asked for it. Well, I also forget.
Is it not really like now that I'm back?
Hold on. I know.
I need to like get up and go for a walk and then like come back up. Maybe I should. Mr. Lake, can I go for a walk? I'll be back in less than 5 minutes.
Wait.
We're going to go over this in just a second. Do you want to wait for that?
For a minute.
What do you need, Sierra?
Okay, so I just didn't register that there was another row.
Those are extra.
Oh,
Yeah,
the
those were
extra.
extra. Yeah.
So then look at the books. So then I missed those. Okay, great. Because I was looking at them and I was a little confused about why my answer is not like that.
All right, guys, let's go through these. Okay, for tangent, what is the period normally for tangent? Pi. So what is it going to be on this one? 2 pi. So we've got 2 pi, 3 pi over 2, 5 pi over 2. It's been a weird week.
Oh my god. Thank God.
All right, tangent is the one that starts at 0, 0. Normally you go up to 1 for your next point, but where are we going to go?
3.
3. Yes, we have a vertical stretch by 3. That does nothing to your asymptote. -3, 0. Okay, how do we do on number 7?
3.
Okay. All right, number 8, we have to think of it as sine, and we need to factor. So I pulled a 2 out. Everybody okay with that becoming minus pi over 2 in the parentheses? And remember, you're factoring it out of everything. Okay, what's the period of this one going to be?
Yeah, like right.
What's the period of this one?
I wish I could do it. I don't like that.
Pi, thank you.
Anyway, no, like. I got another. It's like.
All right, in green, I'm going to do the sign graph with the shifting. Hey guys, please pay attention. I'm doing this for you, not for me.
Yeah, Roger.
Roger gets to watch the video we're making right now. I recorded during 5th, but then it like didn't upload correctly, so I'm recording again. I don't care if you draw that sine curve. It can be there, it doesn't need to be there. Just make sure you get the cosecant graph in at the end. Okay, how'd we do?
So, is it alright if we like leave the sine graph and the cosecant graph like in pencil together?
Totally fine. I am not going to take off if I see the sine curve draw. Yeah, that's fine.
I label it.
Persons?
Why does it shift over to the right?
See how it says x minus pi over 2?
Oh, because it's a minus.
Yeah. Yep. Other questions? Notes, guys. I actually have a worksheet for you to take your notes on today because there's a lot of graphs and
You look like you're in like your hair is like floating. My makeup is really nice. I tested that.
all right, guys. Number 1. Okay, guys, up here. Number 1, I'm giving you all of the pieces of info that you need. Amplitude, vertical shift, and phase shift are easy because those you just use as they are given to you. Period, you have to do a little work to figure out what that actually makes go into your equation, okay? And when the phase shift says like a positive pi, that means you're going to the right pi. So let's try to write this equation. We'll start with y equals, what's the coefficient in the front going to be? Not everybody at once, guys. Yeah, 3, right? Your amplitude? 3. You what?
What is the amplitude?
Vertical stretch. Distance from the midline to the top. Absolute value of A. All these things. Okay, then we're going to say sine, because we said we're writing a sine equation. I'm going to put my brackets. I'm going to leave space for a b value, because we don't know that yet. All right. X, and then it says the phase shift is to the right by pi. So what am I going to write in there? Minus pi? Plus pi would be left.
Minus pi.
Minus pi, okay. And then outside of the bracket, what's the last thing I'm going to write? Plus 4, okay. So the only thing we have to find is the b value from the period. So the period is pi over 2. We know the period is also 2 pi over b, right? So we just have to set up a little equation here of 2 pi over b equals pi over 2. How do you solve that?
Simplify. And cross multiply.
Cross multiply, yeah. So I'm going to have 4 pi equals pi times b. So what does b have to equal?
4.
Yes. So that's the number you put in your equation where the b goes. B. So there's the first one. Okay. So, yes and no. Like, it's pretty easy when all the info is given to you. If I give you just a graph, you have to be able to figure out all that info, so that's what makes it a little tricky. Ugh, okay. All right, guys, try number 2 for me. Try it on your own and then check with your neighbor. What does that do? Check with your neighbor. Do you have the same equation? There's a ghost out there.
How do you find, so you know how in the first one it's X, Y, and Y? How do you know that X and Y is in it?
It's always like sine of x or cosine of x. The x is not the x, y, and the trig function are always going to be there. And then you just figure out. Like, do you see the little format up here?
Yeah. Oh, okay. I see.
Okay. De nada. All right, guys, let's write it. Y equals what?
-3.
Good, -3. Let's see, cosine. Did we have to do anything with the b value this time?
No.
No, we did not. You can put a 1 if you want to, but you certainly don't need to. X what?
+3
Plus
pi over
3 pi over 4. Good. And at the end?
-5.
Excellent. Clearly need bigger lines to write on. All right, try the last one. I mean, the last one of these 3. You know. I know, sorry. You can make it. Less than an hour to go, okay? The first week back from break is always pretty exhausting.
When I was sick,
Yeah, that
this
doesn't
week
help.
I actually felt great 2 days ago. Last day, or yesterday, I felt fine. I got so bad,
Oh no.
I was just like, no, I'll just hold them to coughs for like the next day.
I'll just will myself not to be sick.
Yeah,
I've done that before, where I'm like, you know,
I just like went to bed. I went to bed at 8:30.
My watch doesn't still clock. My watch is probably watching. My watch is done.
all right, guys, let's look.
More time, please. More time.
Oh, that's why I not have time. My watch doesn't still.
Not really. There's not a lot to do here, guys.
If it said reflected in a Y,
It will not. But that would mean the negative is in with the x. Right. We're definitely not going to graph those either.
1 second.
We're starting. Y equals what?
5 over 2.
Positive or negative?
Negative. I put the negative in the wrong side.
Oh, okay. Negative 5/8.
That's a pen.
Sine. Okay.
Wait.
Period was pi. What does that make the b value? 2. What do you mean? Why is it negative 5/8?
Because you have to flip it.
Reflect over x-axis? Yes.
And
Well, you know. And then x plus pi over 4. Yes. Okay. Jude, are you okay?
Got it right.
Oh, good job. Congrats. I thought that was a sad sound. I'm glad it's a happy sound.
No, it was more like, Sophia, you get it right. So,
Oh, it was an arrogant sound. Okay. All right. Now we're going to do this where I give you the graph. I don't give you all of the info. So we have to find that info. Okay. Looking at this, does this look more like a sine or a cosine graph to you? Sine, I would agree. We're going to write it both ways, but we'll start with sine. Okay. Midline is still on the x-axis, right? Remember, your vertical shift is all based on your midline. Like wherever your midline moves to, that's what your vertical shift is. So there's no vertical shift in this one. Is there an amplitude?
Yes.
What is it?
4.
4. Okay. If we write it as sine, there's no phase shift. What is the period? 6 pi, yeah. Now guys, looking at the graph, it's not just what is the last tick mark on the graph, it's actually showing a full cycle of the graph. So like midline to second midline, that's a full cycle, because then it would start repeating.
So on 5, is that 4 pi?
Yes.
let's go.
Yes.
What equals 4?
Amplitude?
Yeah, I just.
I think we're gonna make it today, guys. All right, so our equation, y equals, we've got 4 sine. Okay, period is 6 pi. What does that make b? 1/3, yes. If you're stuck on that, go through the equation, 2 pi over b equals 6 pi. 2 pi equals 6 pi b. 1/3 would have to equal b. Okay, like write it out if you need to. That's okay. All right.
Is there like, how do you do it mentally?
A lot of parentheses. I just think through what would I take 2 pi, like what would I divide it by to get to 6 pi? I'd divide it by a half, or I'm sorry, a third. So you can just write 1/3 x.
So it's always 2 pi divided, that's what the
All right. You could write that as x over 3. That'd be the same thing. Okay. We are going to write this as cosine. Let me show you how. Hold on. I will show you. No freaking out. Okay. The green graph. Does everybody agree that's cosine? Like one cycle of it on the right. Okay. What I'm trying to figure out is how to turn that green graph into the red graph. Do you see that if I just go like that? Okay, so all I have to do is shift it to the right that far. Well, almost that far. I didn't draw perfectly. So the 4 stays the same. The 1/3 stays the same. The only thing that changes is our shift, the phase shift. So what do you think that point is? It's halfway between the pi and the 2 pi.
3 pi over 2.
3 pi over 2, yes.
Not once.
That's the over 2 pi, right? Sure. So you see that the green graph is cosine, right? So if I move it over this far, it's now turned into the red graph. Okay? So I just need to figure out, like, okay, how far did I shift? Do you see how that's halfway between pi and 2 pi? There. On your test, I do ask you to write 2 equations for the given graph. We're going to practice it a bunch today. It will get easier. Okay, let's try again. Number 5, does it look like sine or cosine to start with? Like what looks easier? Cosine. So guys, if you have a maximum on the y-axis, really, or a minimum, cosine's the way to go. If you have a midline point, sine is the way to go. Don't have either of those, good luck. Then it's tricky either way. So try this one for me. Ready, go, Jude?
Yeah, I need to practice.
I did.
Yeah, so practice number 5.
Oh, we're doing that?
Doing number 5. Yeah.
On the test, will we be given like a picture of a graph, or will we be given like the answer to?
Could be either. Probably a graph. And then I'll probably ask you to write both equations. Woo!
Will it be like longer than our
Not really. I'll ask you to graph like 1 or 2, and I'll ask you to write the equation, and that's.
Yeah.
I mean, that's it. I'm not going to have you graph a sine, a cosine, a tangent, a cotangent, secant, and a cosecant. Like, you should know all of them because you don't know what I'm going to ask you.
I think my pencil just broke. And I only have one.
There's a few extras up here if you need one.
I don't know what just happened.
Check with your neighbor. You don't get it? Which part? The b value?
I'm actually taking.
Wait, yeah.
What's
You get the, you get the.
There is no shift if you do it as cosine. Correct. All right, guys. It is 2 cosine 1/2 x, or 2 cosine x over 2. Okay. The b value, do you see the period's 4 pi? Okay. So 2 pi over b has to equal 4 pi. What does b have to be? Okay. Yes. All right. Let me draw in sine, and then we'll practice that.
I just drew sign, but I feel like I drew sign wrong.
Oh, well, that's not going to help you very much.
Wait,
No, I did it right. Never mind.
Does it, like on the test, will you give us a graph and then will you tell us what equation you want? Or will
Say
you just
write
tell us?
both. That's what I mean.
It's like you will in fact doing.
Those. Okay. Again, we're trying to turn the green graph into the red graph. There are lots of options here, guys. I could shift left. I could shift right, like way over here. I could shift right this far, and then what else would I have to do? Flip. Those would all be correct. So I'm going to write it as the shift left. I think that's just the easiest one to see. So again, the 2 stays the same. The 1/2 stays the same. We're going left, so I'm going to say plus, how far are we shifting? Pi. And that's it. Again, lots of options for what your equation could be.
So,
Right, so that's what I was saying on your assessment. I'm going to say, here's the graph, write it as a sine and a cosine. Okay.
It's delayed. Did your b value need to be outside the parentheses for the sign?
Yes. Or it has to say 1/2 x plus pi over 2.
Number 6.
That's what mine said.
That's fine.
Oh no, it just says over. See, that's why I was having.
Just 6 examples.
Yes. Skip 6, but maybe we'll do 6. Yeah, we'll do 6.
so like, why is it 5?
Pi over 2 would only be this far. Sorry. Pi over 2 would be like halfway.
Yeah.
All right, guys, number 6, let's do this one together. All right, 6 doesn't really look like a sine or a cosine, right? It's not perfect either of those. So they both have phase shifts is what that means. Great. Okay, let's do cosine first. Is there an amplitude?
No.
No. Oh, well, you can write 1. Okay, what is the period of this one? It is 2 pi. Yeah, it looks a little funky, but it is 2 pi. That's 1 full cycle of the graph. So we don't have to deal with a b value. Like, you could do from a maximum to the next maximum, or midline to midline, or you could be like, all right, that looks like it's going to start repeating there again. Like, you can check from 0 to 2 pi. Does that look like 1 cycle of the graph? The other ways, like maximum to maximum is fine. You just have to figure out what those points are in between. Or like this point to this point. I know this is negative pi over 4. I know this is 7 pi over 4. That distance is 8 pi over 4 or 2 pi. So the period is 2 pi, so you don't have to deal with any of that. What you do have to figure out is your shift. So think about cosine normally has its maximum right here. Right, this is what that graph is doing. You could shift it left, or you could shift it all the way over here, or you could shift it this far and then flip it. I think just left is easiest. Do you guys see it? Okay. You what? You don't see the left shift? What's happening here? Just keep going. Okay. X plus, how far is it? Yes, 3 pi over 4, good. You also could have said, let's see. Well, because I know everything's like evenly split, so like halfway there is negative pi over 4, so the next halfway would be negative 3 pi over 4. Like you could label all of these in betweens, they're just the over 4s. You could have gone right 5 pi over 4. You could have flipped it and gone right. Not very far, just pi over 4. So lots of options there. Let's look at some. So again, the only thing that's happening with the sine graph is the shift.
I was just writing, and I was very focused. I was looking at my paper, and I looked up, and Maya's face was right here.
Oh, you didn't see her?
And I did not see it.
So guys, you could shift left, not very far. You could shift right all the way over here. You could shift right a little and then flip. Sorry, you could shift left a little and flip. So lots of choices. Where do you want to go, guys?
Right.
Right. Done. X minus how far over 3 pi over 4? Yes. Okay. Number 6 is one of those tough ones where there is no just obvious sine or cosine to begin with.
Why couldn't you just shift it to the left by pi divided by 2?
Okay. So,
That's not the sine of the cosine.
okay. Did it line up?
Shift it, wouldn't it? Oh, wait, no, it wouldn't.
It wouldn't.
Oh, so you'd have to do.
You have to go all the way to where that maximum is, which is 3 pi over 4.
Oh, max, other max.
Because if you're doing cosine, you gotta have the maximums line up. All right, guys, 7 is easier. Does 7 look like sine or cosine? Sine. Okay, the only tricky part on this, what is the period? It is not.
It's hot.
It's pi. Yes, so look, if I go all the way to 2 pi, aren't I like repeating the graph a couple of times by the time I get to 2 pi?
That's so weird.
So we can go, all right, there's one cycle of the graph, so the period is pi. And then think about what does the b value have to be. You can also look at it and go, okay, I see 2 cycles of it by the time I get to 2 pi, so the b value is 2, yeah. So if you saw like 7 cycles of the graph by the time you got to 2 pi, the b value would be 7. Okay. Do I have an amplitude on this one? Yes. What is it?
3.
All right, 3 sine. B value was 2. Nothing else is happening. Okay. Try to write the cosine equation. Anybody think they have it? You might have it in a second. Okay. Sarah, what do you got? You want to try?
Cosine 2 16 sine pi over 4.
That works. Good job. Anybody anything different? You could have gone to the right 5 pi over 4. You could have gone to the left pi over 4 and flipped it.
Draw the cosine graph.
Sure.
Apparently that knowledge is like in my brain. Well, just for this one.
It's tricky. Don't get lost. You see it? Yeah. Okay. Or we could go here and flip here. Okay. All right, guys. Questions before we turn it over? All right, flip the page, guys. We're actually skipping number 5 just to speed things up a little. But guys, on 5, do you see that it finally has a vertical shift? Okay, just making sure we see that. At the end, you'd say -1.
Would it be y equals -2?
No. It would be y equals negative. It would just be,
Yeah.
do just cosine.
I just like stopped reading.
I noticed.
I do that. All right, guys, look at 6. Okay, originally, does it look like sine or cosine? Sine, right? Going right through the midline on the y-axis. Okay. What's the amplitude? 3 sine. Okay. We see less of the graph than normal, right? Would you agree that the right side is half of the graph? Okay, so what does that make the period?
2 or
Hearing lots of what?
We should start counting once we pull eventually.
Isn't from 0 to 2 pi here, isn't that half of what the sine graph looks like? Like, aren't we missing like that part?
Oh, so that would mean that it's 4.
Yes. And again, you see half of the graph by 2 pi. So what is your b value? Yes. How do we get that? So two things, you can either go, I see half of it by 2 pi, so half is my b value, like, that's just the number. Or you can do the algebraic 4 pi equals 2 pi over b and solve for b. Okay, cosine. 3. Cosine 1/2. What would our shift be this time?
Could it just be x minus
-5. Yep. Okay. Don't make it harder than it is. You're just shifting the right by pi. You're looking for where is that maximum? Like how far did I go to get to that first maximum? And that's your cosine graph, okay? All right, 7 and 8. Ooh, okay. They look scary, right?
Yeah.
Secant and cosecant. But remember when we graphed secant and cosecant, how did we start? Sine and cosine. So I'm going to draw in the sine or the cosine graph here. And then we'll just write the equation of that. And at the end, we can turn it into secant or cosecant. Okay. You guys see that the midline is moved up to 1?
So, is it still sine?
Well, you have to pick, is this sine or cosine? Again, you could write it as either one. What's going to be the easiest one? Cosine. It's just upside down cosine, isn't it? Because it starts with a minimum. Yeah? Do you guys see it? It's upside down cosine. Exactly. But yeah, like, so if you have a minimum or a maximum on the y-axis, that's cosine. If it's a midline point, that's sine. Okay? Not just does it go through 0, 0, but an actual midline point.
Would it just be negative cosine?
So, you can just put negative. And I'm going to write it as cosine, guys. What is the period of this graph? I know that it's small on your graph, but can you read it? It is 2 pi. So do I have anything to do with the b value? No. And if I do it as upside down cosine, I also don't have a phase shift. But I do have a vertical shift.
+1.
+1. What, Duncan? And then instead of cosine, what should I actually say as my answer? Secant? Yes. Let's do cosecant.
What's
Just
the
because
point of secant and cosecant? I'm like genuinely curious because they're just like
they're weird graphs.
they're just the same as the other.
They are. They're just the reciprocals. So you have to understand how to evaluate them for calculus. Like they go forever and have asymptotes and are undefined in some places. I know.
Oh.
But are you going to like every day in your adult life be like, and now I'm doing my secant graph for the day? Like,
Well, it wasn't even that. I was just wondering
Yeah,
why
like,
there's
what do you do with it?
why there's a cosine graph and a CP graph or a sine graph and a cosine.
With math, we really like to have inverses and reciprocals and all those things. So, all right. So to look at it as a sine graph, I'm not gonna flip it. I'm just gonna shift. What would my shift be?
Over half.
Yes. To the right?
Yes.
And again, instead of sine, what would I replace that with?
I don't understand why we're racing.
So sine normally would do this. Shift it up one. Do you see that, Duncan? Okay. So all I did to match it up with blue, shift it right. Yes.
So what's the point of writing out sine first when you say cosine? Or
Well, because what we're actually writing, like if we write the equation of the blue graph that I drew in, that's a sine or cosine graph. Your answer has to be the graph of the equation of the red graph. We're actually writing the graph of cosine first. It's going to be secant at the end. That's fine. I just want you to understand sine or cosine, like which one you're picking first. Yeah.
Yeah.
Okay, number 8, guys. So again, I'm going to draw in the sine or cosine graph. Yep.
This won't be on the test book, right?
I finished my speech last night.
What do you mean?
This is gonna be a
Did you ask what she's doing?
Yep. Yeah, this is the last set of notes for Skill 5, so yeah. And then we have review day Tuesday. This is a part of Skill 5 for sure.
Wait. Never mind.
It's kind of spread out here.
It was not an important question.
Do we again see the midline? Okay. Do we see sine or cosine? Okay, y-axis. Is that a max min or midline point? Midline. So that means sine. Okay. Sine normally would go up from there, though. This one goes down. So what kind of negative? Yes, negative sine. Because sine would normally go up.
Why's my handwriting Look. This letter's over here.
Okay, guys, what is the period of this one?
I don't know. Prohibition.
No.
Make my scared.
Okay,
Yeah,
so if we can't tell, do we agree that this much of it? Yes, it is. That from 0 to 2 pi, do you guys see that that's half of it?
Yes.
Right, with a secant or cosecant, you get one downward facing one and one upward facing one. So the downward one took 2 pi. So what does that mean the whole thing's going to take? 4 pi, yes. So the period is 4 pi.
B is 1 half.
B is 1. I'm getting so quick at this. And then what do I need at the end? Plus 1. Oh yeah, and cosecant, yes.
you can always hold the bells in my car. Both of the pile of gum wrappers.
Okay,
She started to.
think about it as cosine, guys. Yeah.
Why is it just cosine? You just go right to
Because it doesn't need to be negative.
Well, I'm writing the other one. Then I'll write it as secant. It's not what? Oh, you could do it as negative. I don't see it as negative though, because I know cosine does like this. So like, if I want that maximum, like I just see the shift that way. Okay, I don't see flipping and shifting, but you could certainly write it with a flip.
Alright.
Guys, I see going left. How far left? Regular pi, right? You take marks. Regular pi. It's like the tiniest font ever, I know.
Well, I couldn't tell when you moved and how many pies.
Well, but do you see that I'm moving it to where that maximum is?
Yeah.
Okay.
I just couldn't tell how many pies that was.
Anna, question? You good? Okay. Get a look for a minute there, like. Okay. All right, guys. Tangent and cotangent. Last two. Stick with me here, guys. There's a lot of squiggles, yeah. Okay, tangent. Do you guys agree that number 9 looks like a tangent? Yes. Okay. The period of tangent is how far it is from one asymptote to the other. So how far is it on this graph? Pi. Is that the normal period for tangent? Yes. Okay. Regular pi. These points also look normal, like there's no really stretch happening. What is the only thing that's happening in this graph? +3. Sophie, put your phone away. So tangent of x +3. Okay?
How do we know if they were doing
The stretch.
yeah.
This point would have, like, so you'd have your center point, then the next one, instead of being like up 1, like if it was up there and down there, like if it got real skinny. They're harder to see. I usually won't give you those on tangent and cotangent because it's tough to read it. If I give it to you, it'd be labeled, like so that you could actually see that that point isn't just 1, how it normally is.
So that's what I said.
What if I supposed to?
Because tangent normally starts at 0 and then is up at 1. So if that point moved. We can also write it as cotangent. Yeah, questions? All right, if this is a cotangent graph, that means it's been flipped. Okay, negative cotangent looks like tangent. And then guys, think about your cotangent graph. It normally has an asymptote on the y-axis. So you can think about shifting that asymptote either to the left by pi over 2 or to the right by pi over 2. Cotangent normally has an asymptote on the y-axis.
So it doesn't have to know which direction.
On the y-axis.
Parent graph of cotangent. You are acting like I am speaking a foreign language.
You might be.
Cotangent.
Yeah.
Okay, that is an asymptote on the y-axis. Yes, okay. All right, so it's hard on
You
a
have
Friday.
to move it over.
Yeah, you just shift it.
You can't just move it as
Well, no, that would not look like the red graph. You have an asymptote on the y-axis. So you could say plus or minus pi over 2. All right, that's all that's happening. The last one, guys, we're going to make it. What does that look like? Cotangent, yes. Is anything happening to it? No, it is the parent graph of cotangent.
It means you can go either way.
Yeah, you don't have to write the plus and the minus, it just means either one works. So to turn it into a tangent equation, we would need negative tangent. And then what is our shift going to be? Pi over 2. And again, it doesn't matter which way you go. Okay? Don't make those harder than they are.
Why does it squiggle in the other direction?
What do you mean? Like, why does cotangent go that way?
What are they gonna
Because
do?
if you think about pi
That's why
over...
it's negative.
Do we have to say plus or minus the same?
Pick one of them. I'm just telling you they both work.
I retract my statement.
Okay, you got it. All right, guys. Any questions? Well, yeah, we're gonna do a quizzes first. No, we're gonna do a quizzes first. Partner up with someone if you would like to. Do it. That was like a sad noise there.